Greetings for the day, sir. My name is Yash Heda. My register number is 20MIS0300, and my slot is C1 slot and of the design pattern class. The topic that I've chosen is the prototype pattern which comes under the creational design pattern. To begin with, a prototype pattern is a creational design pattern that lets you copy the existing objects without making your code dependent on their classes. The concept is to copy the existing objects rather than creating a new instance from scratch. The existing objects acts as a prototype and contains the state of the object. So the newly created object may have changes in some properties only if required. This approach saves a lot of time and the resources, especially when object creation is a heavy process. So the prototype pattern is a creational design pattern, which is a creational design pattern. Prototype patterns are required when object creation is time consuming and a costly affair. So we create objects with the existing objects itself. One of the best available ways to create an object from the existing objects is using the clone method. The clone method is the simplest approach to implement the prototype pattern. Clone method in is the method found in clone method is the method found in java.language package of the Java programming class, which can be used in the prototype which can be used in cloning the objects in the prototype pattern. Now we come down to the real world examples of prototyping. We can see prototyping in biology in the mitotic cell division. After a mitotic cell division, a pair of identical cells are formed. So the original cell acts as a prototype and takes active role in creation of a copy. And the original cell acts as a prototype and takes an active role in creation of the copy. Now the applicability of a prototype pattern, you use the prototype pattern when your code shouldn't be dependent on concrete classes of the object that you need to copy. Now we come down to the pros and the cons of the prototype pattern. The pros of the prototype pattern are you can clone object without coupling to their concrete classes. You can get rid of the repeated initialization code in favor of cloning pre-built prototypes. You can produce complex objects more conveniently. And the cons of a prototype pattern are as follows. Cloning complex objects that have circular references might be a tricky one to create. So we come down to the uses of the prototype pattern. The uses of the prototype pattern are found in Sketchpad and ThinkLab, and a related and the relation and the prototype pattern is related to other patterns also. The most commonly related pattern to the prototype pattern is the abstract factory pattern. So similarly, abstract factory pattern uses the abstract method to produce objects, and prototype patterns creates copies of the objects. So prototype pattern can also be used to create objects. Thank you. Now we go to the coding part of the prototype pattern. Now we come to the coding part of it. We open IntelliJ. I think you can see my screen. Wait, yeah, I think you can see my screen. Wait, screen. Uh, we will now come. Now we will now show you the coding part of it. I open IntelliJ IDEA and we create a new project. This is the new project. I go into BIT design pattern card, new folder code. So over here I create a new project name, prototype pattern, create the new window. So this is the now a main class has already been, well, let's delete this. Okay, so we create a new class, that is a class human class. Okay, so and a main class to call the class human. Okay, Now in the first human class, we declare instance variables, that is int age and int age and string name. Now int age and string name are the two things, and we create the constructor for this class. Uh, Wait, okay, constructor, and we take both these variables. So this is the constructor for the class, your human, and the main uh, we call public static void main, and we uh, we create another class of the we create another constructor of a human class, that is public human, uh, public human human obj, sorry, human obj. So this dot age is equal to this is equal to obj dot age, and this dot name is equal to uh, this dot name is equal to obj dot name. So this has been done. Now we call the human class human. I'll give my name Yash is equal to new human, and pass values as my age is 18 and name is Yash. Age is 18 and name is Yash. So these are the values I pass. Okay, and I create another object, human twin is equal to new human Yash. So now these are the object has been copied, but this copying of object is a lengthy process, and it takes a lot of space and time of creation. So this is a normal creation of an object. We can verify this by finding out Yash dot name and uh, twin dot name. Now these two names will be the same when we run this. These two names come out to be the same. Now, but this process is a copying of these objects is a very lengthy process. In order to shorten this process, we use the clone method, which is used in prototype method. In order to do that, first let me comment this two out. And we use the clone method. New uh, new wait human twin is equal to uh, Yash dot clone, and of clone of the human class. So we need to add human here, and over here we need to implement the clonable interface. Clonable clonable interface. Yes, clonable interface. So here we implement the clonable interface. Now clonable has been implemented, and yeah, over here the clone method has been called, but there's an error here, and no. Huh. So here we click here. Okay. So now we have to throw an X. Here we need to create the overriding method, which is the clone method. Okay, this has been done, and we need to add exception case to it. Now the clone method has been created, but this kind of type of cloning is a shallow cloning. But we'll still run this and see if it works. And I just remove the comments from here, and make this and run this, and this will still work. You see, this will still work if you just tell SOUT twin dot age. It will still work. Now I remove these to this class also, this constructor also. I comment this out, and this will still work because we have used the cloning method. You see, there's no change in of objects. But here there's a problem. The problem here is that the cloning here is shallow cloning. So shallow cloning, what is shallow cloning? There are object. The object is one. There are two kinds of reference variable, that is Yash and twin, pointing to the same object. So any change in one, any change done by Yash to the object reflects in twin also. So this is called a shallow cloning. Let me show you an example of this. Int int ARR. So int ARR, and this dot ARR is equal to new int 3 4 1 2 3 4 5 1 2 3 4 5. All right, and now I print first of all twin dot ARR. I comment this out first. Comment twin dot ARR and Yash dot ARR. So it will give me the same 1 2 3 4 5. Okay, there is some problem. Twin dot. Okay, sorry. We use arrays dot toString method. Arrays arrays dot arrays dot toString method twin dot arr, and similarly yash dot arr. Copy it down and change this to yash.arr, and running this will give me the same answer. Okay, but any changes done by twin.arr also reflects. So twin.arr of 0 is equal to 100. Sorry, 100. And if we use that in, if we call these two print statements again, if we just call these two print statements again, uh, so any changes made by twin.arr is also reflected in yash.arr. So though two reference variables point to the same object, so any changes made by one also reflects in the other. This is called as shallow copying, and in order to avoid, it's recording, right? Yeah. In order to avoid this, we do deep copying. To do deep copying, we do little tweaks in this method of clonable. Here, we change this. So human twin is equal to human super dot clone, and twin dot arr is equal to int new int uh, twin dot arr dot end, twin dot arr dot length. uh, we run the for loop for this. For I is equal to 0, arr dot length I plus plus, and then twin dot arr of I is equal to this dot arr of I, and we now return the twin method. Return twin. Now in this case, any changes made will uh, sh- uh, any changes made by the twin method will reflect in the twin object reference variable only, and it won't reflect in Yash's object variable. So this time, so from this we can move from shallow cloning to deep cloning. This is the prototype. This is the code for the prototype pattern. And thank you.